Okay, so Meta, that's basically Facebook, has launched Llama 4. In fact, it's announced 3 models in the Llama 4 family. In this video, I want to go through the announcement, and then we're actually going to test Llama 4, the middle-sized model, which is available today, and see how well it does at logic questions, English questions, comprehension questions, programming questions, the whole thing. So if you want to find out more, please let me explain. Okay, so Meta has announced 3 models, 2 of which are available now. We'll start with the smallest, Llama 4 Scout, 109 billion total parameters with 16 experts, and the 17 billion active parameters means that because this is a mixture of experts, at any one point 17 billion parameters have the potential to be used because the other experts are quiet, if you want to put it that way, as you're interrogating the large language model. Now, it has a 10 million token context length, which is just absolutely astounding. So it'll be interesting to see what tests can be created that can have an input of 10 million tokens. Certainly not doing that today. That's way more than I can do. So Llama 4 Maverick, is the one that is their leading one at the moment. So 400 billion parameter model with 128 experts, again with that same 17 billion active parameters and a 1 million token context length. They've also announced their Llama 4 Behemoth, which is a 2 trillion total parameters, so that's just unbelievably huge, and it's going to be so interesting to see it. It isn't ready yet. They've got some issues to solve with that, some more training to do. 288 billion active parameters at any one point, 16 experts. It will be interesting to see when that comes up. But today we're going to be focusing on Llama 4 Maverick. Okay, so I'm using a website called together.ai. I'm not affiliated with them in any way whatsoever because the models that Meta release, they don't have a kind of a chat GPT service necessarily that you can just go to. So this company offers these models along with loads of other models here. As I said, I'm not affiliated with this at all, but there you go, that's how you can use it. And so we're going to be using Llama 4 Maverick, and we're going to ask it some questions, and let's see what kind of answers we get. So let's start with our Alice question. Alice has 5 brothers and 3 sisters. How many sisters does Alice's brother have? The answer, of course, should be 4. Let's see what the model gives us. So it's going through understanding how we get final answer 4. Okay, so there you go. I was expecting that to be right. This really is kind of an easy question now for these large models. So well done there to Maverick. Okay, next question. You are an English teacher helping a student with an exercise. It's important that you follow these instructions precisely. Read the text, pick an unusual word, find a one-word synonym for it, and then give the reverse of that word. So basically several steps. So it needs to understand the steps it needs to follow and the text it's trying to read. And quixotical is normally the word that most large language models pick, and then they try to pick a synonym for that, and then the reverse of the synonym. So let's have a look. It's read the text. So yes, quixotical, it's fine. Impractical is what it said, and then the reverse is IMPRACTIC. Yes, correct. Brilliant. So it's managed to follow the steps, read the text, and produce the reverse of the word, which is actually quite challenging for a large language model, and it's done it. So that's great. Okay, so here is the first of my 2 hourglass questions. This is the simpler one. Love to hear your thoughts on how you solve this in the comments below. You have 2 hourglasses. One measures 10 minutes, the other measures 5 minutes. Using only these 2 hourglasses, can you measure exactly 15 minutes? If so, explain the steps involved. So most of the big models get this nowadays. So let it finish coming out. Okay, so we're reading just step 7. I'm not going to read all the other stuff. Start both glasses. Okay, when the 5-minute hourglass finishes at 5 minutes, flip it over. When the 10-minute hourglass finishes, the 5-minute hourglass will have been running for 5 minutes since it was flipped. Wait for the 5-minute hourglass to finish again. This will be 15 minutes. So it's almost right. I mean, obviously the simplest answer is you flip the 10-minute one, then the 5-minute one, and that's it. When the 10-minute, step 3, when the 10-minute hourglass finishes at 10 minutes, the 5-minute hourglass will have been running for 5 minutes since it was flipped. Wait for the hourglass to finish again. So we could say that finish again means it's implying that you flip it again and then you get the extra 5 minutes. Yeah, it doesn't explicitly say anywhere that you have to flip that the 5-minute one again. But since it says wait for it to finish again, I'm going to say okay. But there's a harder question coming up. Let's see if it can, with hourglasses, let's see if it can cope with that. Okay, you have 2 hourglasses. One measures exactly 7 minutes. The other measures 11 minutes. Using only these 2 hourglasses, can you measure 15 minutes? If so, explain the steps involved. So let's see what it does. So it's going to give us all of its kind of output here. Hopefully it'll give us a nice summary at the end, and then we'll be able to just follow that through. Okay, so simplify the measure. Start both hourglasses. When the 7-minute hourglass runs out, 7 minutes, flip it. No, it's basically got it wrong. It can't do it. That's a real shame. So there you go. It can't do it. Other models like the ones from OpenAI, the bigger ones, you know, O1 can do this. Gemini 2.5 Pro can do this. So fail, I'm going to say there. Okay, let's ask it a bit of a programming. Write a Python program. It takes the phrase Gary explains with an exclamation mark, count the total number of alphabetic characters in that phrase, ignore punctuation and spaces, multiply that count by 7, convert the product to hexadecimal, reverse the digits of the resulting hexadecimal number, and finally print it out. So again, following steps in writing a program. This is important because if you want to write a program, you want to tell it what you want a particular function or a particular bit of code to do. You specify that in English and it converts it into code. Let's see how well it can do. So it's given me some code here. Okay, so let's run that. We'll run that now in the web browser. Okay, so here's the code that it's given me. Let's run here. The answer is 4.5, which is correct. That is the correct answer. So it has done the right thing. Okay, another bit of a programming. Create the specification for a simple encoding method similar to ASN1 or to protobuf, that's from Google. The scheme must use a simple type length value encoding with support for primitive types including 8-bit integers, 16-bit integers and so on. The encoding is flat and cannot include subobject. That makes it just simpler for the large language model to do. Make the specification detailed enough for a programmer to implement. So that's what I wanted to see, if I could get it to come up with a specification that I could then hand to a programmer. Of course, between me and you, that program is going to be itself in a moment, but it's actually giving us the technical layout of this, and it's doing it. Looks like it's okay. It's giving me the values here for the encoding. You know, when you see a 5, it's going to be 128-bit, you know, integer and so on. That's the idea. Okay, and then so that looks good. That's a pass so far. And then the next thing we say is, well, actually do it, please. So write the C code to implement the encoder and the decoder, including unit tests. I'd like a make file and a readme file, please. So let's go ahead and ask it to do that. And so it's giving me some code here, a H file, the C file. Okay, that looks okay. And then we want to see what the unit tests come out to be like. This is the important thing. So it's doing all the different types there. As you can see, ASCII, UTF-8, Boolean, float and all that. And now it's doing the decoder. So it's going to go ahead and unpack something when it sees it. Right, unit test, here's the important thing. Test UTF-8, test Boolean. Okay, oh, I was hoping it was to test a few more things. Let me just scroll up here. So it's testing intake, test UTF-8 and testing Boolean. Well, that's only 3 types. It could do, you know, I'd like some full coverage there, but okay, it tests to see whether it works. And what's it doing? It's basically the way it does it. If you take hello world, it encodes it and then it decodes it, and then it basically compares value, which is the hello world, with the decoded value to make sure you basically go full circle. So you take the thing, you encode it, you decode it, and then you come back with the full thing. So what I'm going to do is I'm going to take that code and see if it builds. Okay, so here I am in Windows Subsystems for Linux. I've got the different files that it's asked me to make there, to create there, including a make file. Moment of truth, let's just type make, missing separate. And that may be because of tabs and spaces. So I'm going to give it the benefit of the doubt there because I just copied that. Let's just make these tabs, these spaces into tabs, because it's literally a cut and paste, and you can forgive that. But that's probably my fault rather than its fault. Oh dear. Okay, lots of errors. Do we kind of go around and ask it again? Yeah, let's do that. Let's just cut and paste all of this and give it a chance. We'll give it one chance to fix it. Okay, so I've corrected those files as it told me. Let's type make. Yes, now it runs. And let's run tests. All tests pass. Well, we know there wasn't full coverage in those tests, but it gave us 3 test. So that's a good. So I'm going to say pass for that one. Okay, another programming test. Let's see how it does in creating machine learning programming. So write a game of tic-tac-toe which uses machine learning. Write the game in Python. There needs to be two modes. The training mode will repeatedly play itself and learn a strategy to win. The other mode is to play against a human once the training is done. Give me a... Now I did this on Gemini 2.5 Pro. Worked absolutely brilliant if you've seen my video on that. Okay, this is looking good. Train mode and a play mode. So let's see the Python code that comes out and let's give it a go. Right, it's giving me some talking. It's telling me it's using the Q learning algorithm. Okay, let's just copy this one file, isn't it? Yeah, okay, so we'll just copy that code. Python 3 tic-tac-toe. Okay, train the AI. Number of episodes 50,000. Okay, boom, 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 boom. Okay, to play the AI. Okay, well, it hasn't given me a grid. That's a bit disappointing, so I can't see what's going on, but I know 5 should be the middle. Okay, and it's put one up there, so now let's go with 1, 2, 3. Okay, well, it's left me open, so I can now go with 7, and I've won the game. Right, well, that didn't do very well, did it? Okay, let's train it again. Let's try 100,000. Okay, we'll give it the benefit of the doubt, see whether it can, it will learn better. Okay, play against the AI. Okay, we'll go again. 5 in the middle. Oh, it's playing the same game again. 3. Well, it played the same game again. Okay, so no, it couldn't beat me. The one that Gemini 2.5 created played a mean game. It either won or it gave me a draw basically in every time I tried to play it. So not so good there. So I'm going to say no. Okay, I've got an infographic here of a Spectrum ZX81, and what I'm going to ask it to do is describe this image like Shakespeare. So it has to understand the image and then it has to create a description about it, but using "O fair ZX81, thy visage doth bespeak a tale of innovation in days of old. A Sinclair device with a keyboard so fine doth boast a lowly price to make it shine." Okay, that's good. So it's managed to understand it's a ZX81. It's talking about the price. It's talking about that it comes from Sinclair, which is something that's just written on the image itself. So I would say it's done a good job of recognizing that and then describing it as Shakespeare. So that's a pass. One of my viewers, Craig Step, with an E at the end, I don't know if it's Step or Step E, he sent me a brilliant picture that he's been trying himself, so I'm going to use it. He's got some dice here that he took, that he basically did them threw them on the table, and of course you can see multiple sides because it's not a top-down shot. So he's asking what are the top values of the dice, and so it's saying the top values are 5. There is a 5 in there. There is a 4 in there. There is not a 6 in there, so there's not a 6 face being shown anywhere. There is no, basically it's completely wrong. So to be honest, nothing gets this right so far. Not any of the ChatGPT ones, even the bigger models, not Gemini. That's a fail, but in good company. Now, normally at this point, my final test is to get the large language model to create a chess engine that can talk over the universal chess interface. I give it quite a detailed prompt with the specification, pointing out what it needs to support and the method it should use for deciding the chess moves. Now, none of the other large language models have managed to do that in one shot. And because this has struggled with that Python program playing tic-tac-toe, because it struggled with the program for the simple type length value encoding, then it's definitely going to struggle to do this. So I'm not going to do it because by the time it produces like 6 or 7 files and then I have to copy them all in and create the files, I feel it's going to be too much, knowing I'm going to be disappointed. Now, if you think I'm being unfair, do let me know in the comments, but I'm just not going to try because I don't think it's going to do it. Okay, so there you have it, Llama 4 Maverick. Really, I'm a little bit disappointed. I think Gemini 2.5 Pro is really just amazing. I think the models from OpenAI are probably better than this as well. Now, we'll have to see how that bigger model turns out. I mean, 2 trillion parameters, that's just enormous. So that will be interesting. But for the moment, sorry, Meta, not as good as I was hoping for. but do let me know what you think in the comments below. Love to hear your opinion. Okay, that's it. My name's Gary Sims. This is Gary Explains. I really hope you enjoyed this video. If you did, please do give it a thumbs up. And if you like these kind of videos, I invite you to stick around by subscribing to the channel. Okay, that's it. I'll see you in the next one.